This is a pre-built version of the application. So if we go ahead and run it, now suppose a company's hiring decisions are based on two interviews, and we have hiring and candidate interview scores data, and the score for each interview is on a scale of 0 to 10, and this is the score for candidate interview number 1, and this is the score for his second interview. And logistic regression with stochastic gradient descent was implemented here, and we discovered this decision boundary, and the candidates to this side of the boundary were not hired, and those to this side were hired, and those two candidates were misclassified. Now let's go ahead and classify some new candidates and try to predict based on their interview scores if they will be hired or not. So a candidate with those two interview scores, the probability that he will be hired is this number. So he was classified as 0, which means we have a will not be hired prediction. I will start by creating a new Python file, and here we will use the same training data we used on the previous tutorial. So this column is the bias, and this column is the score for interview number 1, and this is for interview number 2, and 0 indicates that the candidate was not hired, and 1 indicates that he was hired. And we need to import both NumPy and Matplotlib, and we will put the feature data in XArray and the label data in YArray. So gradient descent uses all the data set each time we do an update, but with a huge number of records and possibly a huge number of features, this algorithm becomes very expensive computationally. Now stochastic gradient descent is when we update the weights one instance at a time. So the calculated hypothesis and error are single values instead of vectors, and the step size alpha changes on each iteration, and the weight update instance is selected randomly. And this is logistic regression implementation from the previous tutorial, modified to include a stochastic gradient descent implementation. So the step size alpha changes on each iteration, and the weight update instance is selected randomly, and the calculated hypothesis and error are single values. And let's go ahead and instantiate a logistic regression instance. And call the stochastic gradient descent method and get back an array of weights. And this function uses matplot library in order to plot the decision boundary and the interview scores. And this function handles classification for new candidates. So it prompts the user to enter interview scores and calls the classify method, which will return a string. So it will indicate if that candidate is classified as not to be hired or to be hired. And finally we will call those two functions from here. So first we prompt the user to close the display window to proceed, and then display the plotting window, and then handle command line. And finally let's go ahead and test run the application. So those candidates were not hired, and those candidates were hired, and this is the decision boundary that we discovered, and those two candidates were misclassified. And let's try to classify some new candidates. So the probability that this candidate will be hired is this number. So he was classified as 0, which means that we have a will not be hired prediction. And if we have this candidate with those two scores, then the probability that he will be hired is this number. So he was classified as 1, and we have a will be hired prediction.